is going to be dynamic, I'm sure. So earlier you heard, well, this is going to be a sort of now for something completely different. No, stop, break, it's not at all. Because you saw neurons illustrated in what's called a neural net system. The question is, those aren't real neurons. Those are computational units of hardware. The fact that you're able to perceive that is because you've got real neurons. The question is, how do we intersect the real neurons with the neurons you saw earlier? And what is the reciprocity of the nature of those interfaces as both that technology increases and becomes more ubiquitous, and therefore it prompts us to not only consider using those technologies, but generate concerns over the ways we can, the way we do, and the way our adversaries are already doing so. So in terms of disclaimers and so forth, if I can get this to work, which of course I cannot, there we go. The usual disclaimer. Like Dr. Evans, my work has been funded over the past several years by a number of governmental entities and institutions. Nothing that I'm saying here necessarily reflects their position on this, although much of the work was done under their auspices as well. The construct here is very, very simple, ladies and gentlemen. It's simply this. We can zap the brain and modify the mind. Let me tell you how that goes. We simply don't know how mind occurs in brain. I've been a brain scientist for 42 years this year. I know, that's a long time. I look in the mirror and I go, how did that happen? But a lot of the stuff that I learned when I was in school as a neuroscientist and as a neuropathologist does not obtain any longer. There's an interesting dance that happens between the tools that we have at our disposal and the theories we create, and then pressing the limits and the envelopes of those theories through ever new tools that we then create, both heuristically and practically. And the issue there is, are we ready for AI? Is human intelligence ready for AI? Are humans intelligent enough to engage with AI? And how will we design those systems to interface with humans? So essentially what we see is the brain computational, the brain-machine interface writ large. And if we look at discrete domains of where these BMIs or BCIs create new scientific and technological innovation intersections, they can be parsed into three categorical domains. Number one, those that are used to assess the structure and function of the brain, and understand that the underlying paradigm is that it's not just a brain that's a bunch of squirty, squiggly cells. This is a brain that is embodied in an individual who is embedded in an ecology, and that ecology has a context, and the context is the military operator, the intelligence operator, either the trigger puller or the individual who is in some way contributing to the force readiness and preparedness of that military. But that's a human organism. And the question is, how can we keep that human organism functional in that particular contextual job? One way is to understand how their brain works. And if we can understand how the brain works on a variety of levels, we may be able to sidestep the proverbial hard question of the neurosciences. How does brain occur in mind? This is proverbial, I mean realistically. If we have a large enough pattern repository of data and we can use those data, we can make maps. We don't necessarily have to know how it happens, we just have to know where. Because those maps are targetable, which then brings us to the next phase of brain-machine interfacing, which is interventional brain-machine interfacing. And these run the gamut, some things we can do peripherally that are donnable and doffable that can hook up to our physiology somatically and therefore affect our nervous system bottom up. Things that are donnable and doffable that we can put into headsets, helmets, wearables, semi-wearables, and ever more those things that are indwelling and that need not necessarily be a surgical implantation, because state-of-the-art now is for next-generation non-surgical neuromodulation. Inhalables, ingestibles, deliverables via very, very small-scale units at the nanoscale that can then be segued to where they have to go in the brain and form literally vast arrays of sensors and transmitters to be able to real-time and remotely read from the living brain and write into the living brain. That sounds like sci-fi, doesn't it? It's not. This is a project at DARPA that I have the honor and privilege of working on called the N-Cube Project with my colleague Alamondi. This is a Heilmeyer catechism for 60 calendar month evolution. So in 60 calendar months, we will be there. Why is that important? Because our trans-Pacific near-peer competitor will be there in 42 months and has already made inroads for a number of reasons, not least of which is because there are different cultural systems there, different philosophies there, and different ethics there that have very different permissivities and constraints. But more and more, we're intersecting and interacting with our trans-Pacific and transatlantic peer competitors, cum adversaries, and the question is going to be, in what ways? Cooperative ways, competitive ways, combative ways, and what does that then portend for the new battlescape of the 21st century, which is here? All those things we've seen this morning about what AI and machine learning does, it's to augment the human system in some way, with information, with awareness, with sensibilities, sensitivities, with morality, from the machine, from us, having a human in the loop or on the loop, and that is not a universal consideration. But more than that, what AI allows is the utility of the brain sciences to be able to take massive amounts of discrete data and integrate those into ways that are operative for making decisions about assessing what the brain and the individual whose brain it is doing, what their intentions are, what their directions are, and what their behaviors will be.